This is going to be the final video on inorganic nomenclature or naming, and in this video we're going to deal with the nomenclature of acids. Two types of acids we can deal with: binary acids and binary oxyacids. And so let's get started on those. So first of all, in terms of acids in general, so again we're dealing with hydrogen, and it has a charge of +1, so that should indicate to you it's acting as the metal, so it's going to come first. Now the other thing about hydrogen is it has a reasonably high electronegativity, and it's going to form covalent bonds with more electronegative nonmetals, and what it appears like on the surface is that they're ionic, when in fact they're covalent bonds. They're not ionic. So you don't really have to worry about this too much, but just be aware of that when we start dealing with differences in electronegativity. So when we dissolve these hydrogen-containing compounds in water, what actually happens is they split apart and you get free hydrogen ion in solution, and so when they're dissolved in water they're said to be aqueous, or we add the symbol AQ afterwards, and when they're aqueous they have acidic properties, hence acids. So in the first instance, HCl with nothing else after it can be considered a simple binary compound. If we're naming that, we just call it hydrogen chloride. But if we add the aqueous symbol AQ, it means it's dissolved and now it has acidic properties, so we're going to call it an acid. And so you've heard of this acid before for sure, hydrochloric acid. And so that's the new bit, the ic acid. So aqueous or acidic binary compounds get a name change, and there's how the ending is dealt with. Okay, so here we go. Here's the system. So hydrogen or acid is formed when hydrogen combines with a nonmetal in solution. That's the important bit, in solution. So if it says aqueous, it's definitely specifically in solution. Formula for the acids is the same as the ionic compounds in terms of metal. It's always hydrogen, then the nonmetal. But then to name it, it's a little different. So we have to follow this pattern here. So here's that hydro first. So we always add this prefix hydro. Then we have the stem of the nonmetal. And by stem of the nonmetal, I mean something like chloro or chlor for chlorine. And then we add this ic acid. So hydrochloric acid. So something like HBr. So we know it's an acid because of the aqueous, so we're going to call this hydrobromic acid. And then hydrofluoric acid, well, we know it's an acid because of the name, so we know it must be H, fluorine is F, and then we add the aqueous to indicate that it's in acidic form. It's in its dissolved form, which makes it acidic. So binary acids, the nomenclature is really quite straightforward. Simple formula as you know how to do before, but don't forget the aqueous. To name it, you have to follow this pattern: hydro, stem of the nonmetal, and then add the ic acid suffix. Now another type of acid is known as oxyacids. And so oxyacids formed again when hydrogen combines with an oxygen-containing polyatomic ion. So now we have these polyatomic ions on board. So the formulas get a little more complex, but not really, because we're just dealing with polyatomic ions. So again, formula is exactly the same: metal, hydrogen again, then the polyatomic ion, and a name, just like we did with the binary acid. You have the stem of the oxyacid, or oxygen-containing polyatomic ion, and then ic acid. So what's different is there's no hydro prefix. Okay, so H2SO4 as an acid would be called sulfuric acid. And so it's sulfuric acid because it has this polyatomic ion, therefore there's no hydro prefix. Hydro really indicates hydrogen. In this case, sulfuric acid, the sulfuric indicates the polyatomic ion, and it's an acid. Chloric acid, so the chlorate ion, This comes from the chlorate ion, and the chlorate ion is ClO3-, so it's going to be HClO3 aqueous to indicate that it's acidic. So again, binary oxyacids are not a whole lot different either. Here's a few examples. So H2s, binary acid, hydrogen and sulfur. So this is hydrogen or hydrosulfuric acid. So it's binary because it's not an oxygen containing polyatomic ion, so it's hydrosulfuric acid, that stem of hydro. Hydroiodic acid, Hi aqueous, hydrogen and iodine. H2CO3 aqueous. So this is carbonic acid. And phosphoric acid, so that comes from with the phosphate polyatomic ion, PO4 3-. So if you need 3 hydrogens, H3PO4 aqueous. And finally, I've just included H2CO3 again, but notice here there's no aqueous, so there is another acceptable name for that, which would just be hydrogen carbonate. So remember, if we have the aqueous, it's an acid. If you don't have the aqueous, it can be an acid or just a simple ionic compound. So that's the types of acids you should be familiar with: binary acids and oxyacids, acids containing polyatomic ions. And that concludes this video.